All the gas laws come from the ideal gas law. The ideal gas law says that the pressure times the volume is equal to the number of moles times the gas law constant, which is known as R, times the temperature. And the temperature is going to be in Kelvin. Now, over here on the right-hand side, I have what R is equal to. R is equal to 0.08206. And all those units right there, they are what help you go from a temperature unit to a pressure unit, or from a volume unit to a mole unit. Now, PV equals nRT is referred to as Pv-nRT in the chemistry world. So that's just a fun way to remember the ideal gas law. So I said all the gas laws come from the ideal gas law. Let me show you. So let's look at Boyle's law. When we look at Boyle's law, we have Pv-nRT. Now in Boyle's law, the temperature stays the same. So I can cross that out. And I also have the same sample of gas, my N. And R will be the same. So I end up having P times V. Well, if I put that equal to itself and call it situation 1 and situation 2, there's Boyle's law. So let's look at Charles' law. So in Charles' law, we have first Pv-nRT. And in Charles' law, we have something expandable like a balloon because the pressure stays the same. So I can cancel that out. I also have the same sample of gas, so no N, no number of moles, and then R will be the same. So I end up having V equals T. I can divide each side by T. So I end up having V over T is equal to V over T. And this is Charles' law. So situation 1 and situation 2. And we also can have our combined gas law. So again, start with Pv-nRT. And in the combined gas law, we have the same number of moles. And also the gas law constant will be the same. So let's get T on the other side. So divide both sides by T. And I end up with P times V over T and P times V over T. So I have situation 1 and situation 2. So there's the combined gas law. So they all come from the ideal gas law. As I've said before, 1 mole of any gas is always 22.4 liters at standard temperature and pressure. And remember that standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. When we have Pv-nRT or PV equals nRT, when we're using that, we need to be in the atmosphere units. So let's look at this problem. So 52 grams of oxygen occupies what volume at standard temperature and pressure? So here's PV equals nRT. And I want to solve for volume. So I'm going to divide each side by pressure. And I get volume is equal to nRT over P. So let's identify what each thing is. So we do know our pressure. Our pressure is 1 atmosphere. Our volume is what we're trying to find. Our number of moles, we actually don't know, but we are given how many grams. So we're going to convert from grams to moles, and then that will be our mole number. We know R, 0.082. I'm just going to round. And our center temperature. So let's go ahead and figure out how many grams are in that 1 mole. So this is something I need to do before we get started. I didn't leave myself a lot of room here, so let's just do it right here. 52 grams of oxygen. And looking on the periodic table, 2 oxygens, so 16 plus 16 is 32. And that's how much is in 1 mole. And we can divide through, and our number of moles is 1.625. So that's how many moles. All right, let's go ahead and plug into our volume here. So our moles, we have 1.625 moles. Our R is 0.082. And go ahead and add all the rest of the values. Let's cancel out our units. So our moles cancels. My Kelvin cancels out, my atmospheres cancels out, and I'm left with volume units. And so when I multiply this out, I get 37 liters. So I only have 2 sig figs. There's another way to do this problem using some stoichiometry, but Pv-nRT works also. So this is a problem from your homework. It should be question number 35 or something close to it. So again, I have PV equals nRT. And let's identify what we know. So our pressure is given to us 0.85 atmospheres. Our volume, we have 0.65 liters. N is our number of moles. That's what we're trying to find. Our R is that gas law constant. And our temperature is a negative 15. So remember, our gas law constant, it is in Kelvin, so we do need to change it. So there's that Kelvin unit. So I need to do 273 minus 15, and my value is 258. So let's solve for n. So I'm going to divide each side by r over t. So n is equal to P times V over R times T. And I can plug in our values, so 0.85 atmospheres. My units will cancel, so I get atmospheres canceling, liters canceling, Kelvin canceling, and I have moles in the denominator of the denominator, so when I divide, that's going to flip up. And my number of moles is 0.026 moles. So I only have 2 sig figs, so I'm going to have 2 sig figs in my answer.